Well, hello there again. I'm sure you were missing the sound of my voice and wondering when you were going to get yet another installment of these thrilling and exciting videos. So here you go. Um, so to get started, I want to kind of remind you that they've cut back on some of the topics that we actually need to cover in this particular section. So, or I should this unit. So I'm going to kind of take one step back and then move forward. Just to remind you, we've been really focusing on geometric series, so that's the first one that they say that we really need to know from this unit. After that, we did several. We did the nth. Well, before that, we did the nth term test. We did um, telescoping. Neither of which are going to show up on the exam, according to what they say. And then we went to integral test, which also is not going to show up on the exam. But P-series will show up, and I know that we've talked about P-series a little bit, so that's going to be kind of my one step back today, just a real quick refresher on that. And then we'll go forward into the next part that they say is going to be on there, which is the ratio test. So the homework for today, that's due the next class, is going to be a few problems of P-series, just so we can kind of do some refresher on that. I know we spent so much time on geometry because I really wanted to drive it home, but P-series can be an easy one. I just want to make sure we're okay and we're ready for those. And then you also have some homework on the new stuff that I'm about to show you. So really, once we do that, once we do the new stuff for today, then there is, if I'm thinking correctly, there's really after that just two more sections of new material. So really, in about a week or so, we can be done with the new material and start reviewing. And we will go back and start from day one with limits. And I'll just kind of really help you to maybe organize and chunk the material into sections so we can kind of go through with a pretty quick refresher. Okay, all of that to say, here's where we're going to get started. Remember for P series, here we go. Remember for P series, it's uh, it's the idea where you have 1 over n to the p, right? So it might be 1 over n, it might be 1 over n squared, it might be 1 over n cubed, whatever. So it's all about what that exponent is on the denominator. Remember how we said if the exponent is greater than 1, it converges. If you have 1 over n squared, 1 over n cubed, 1 over n to the fourth, series converges. We said if it's between 0 and 1, so maybe if you have 1 over the square root of n, or even just 1 over n, then the series diverges. And in fact, I gave you a special name. That 1 over n is called the harmonic series. Um, and so those are pretty easy to pick out. So the series from 1 to infinity of 1 over n, well, the p is 1, so we know that's a diverge, and I mentioned that it's called harmonic. And I also mentioned last time that we can kind of generalize this next one, even though it's 1 over 2n plus 3. As far as we're concerned, that's the same as a 1 over n. It could be 1 over 5n plus 100. Still, as far as we're concerned, that's just like a 1 over n. So it's still going to be a diverge. We call it a general harmonic. And last time I showed you how it can be proven by the integral test, but we don't care about that now because we're not going to do an integral test anyway. And so we did a quick refresher, well, not refresher, but we did a couple of quick examples. Hey, on the first one, if p is 1/2, definitely it's a diverge, right? On the second one, if you combine those, the p is 3/2, so it's definitely a converge. And so they're pretty straightforward, pretty easy to tell for the p series. Okay, so here's where we're going to move into a little refresher that we haven't done yet. What I want you to look at here, though, I don't want you to necessarily try to go through a test, but just think about, for example, number one. If I have 1 over n cubed plus 1, like I said, I don't really care about the plus 1. That, as far as I'm concerned, that's just a 1 over n cubed, so it's got to be a converge. And in my mind, I'm going to think of it as a p-series. And so do you see that for 1b, as I go across, if you have an n over n cubed, as far as we're concerned, we're going to think of that as, what would you think? What kind of a p-series do you think that we might think of that? Well, I hope you said we're going to just think of that as like a 1 over n squared, because think about if you simplified n over n cubed, it would just be n squared. And if that's the case, then that means it's going to be, well, if I could get my little handy dandy thing here to work, then that means it's just going to be a converge. Okay, what about the next one? If you have an n squared over n cubed, well, we're going to think of that as um, we're going to think of that as 1 over n, and so that would be a diverge. Okay, so with that in mind, can you look at that second row all the way across and see if you think it would be converge or diverge? Try it. Try the second row, number 2, 2b, and 2c. What do you think? So how'd you do? Number 2, did you think of it as just 1 over n, so it's a diverge, right? 2b would be like a 1 over n, so it's a diverge. The next one, oh, that's like a 1 over n squared, so that would be a converge. Okay, now when you get to the third row, is this p series? No, it's not 1 over n squared or 1 over n or 1 over n cubed, but come on, come on, make me proud. What are we? All of number 3 we're going to think of as what kind? Right. Hopefully you said geometric series. And if that's the case, then when I look at number 3, that 2 to the n over 3 to the n, I'm going to see that as, well, I thought I was going to see it as something. I'm going to see that as 2 over 3 to the n, right? That's why it's a converge. The next one I'm going to see as 3 over 2. Oh, so it must be a diverge. And so now we're going to generalize on 3c, and that's going to be, hopefully you're thinking diverge. Okay. So what about this one? What about number 7, that row all the way across? What do you think? These would be forms of P series. Well, did you get diverge? Because that's 1 over n to the 1 half. 7b, if you think of that as, let's see, you have like a 1 over n times, and then 1 over the square root of n squared. Wouldn't that be like another 1 over n? Which is kind of like a 1 over n squared. So hopefully you said converge. And then 7c, if you simplify that, that would be like a 1 over the square root of n. So that would be a diverge. All right, what about row 8 all the way across? What do you think? Hopefully you're thinking of number 8 as geometric. So on number 8, it's kind of like a 2 times. It's like a 2 times 1 over e to the n. So therefore it's got to be a converge. And then 8b is like a 2 over e. Remember, e is 2.7, so that's a converge. And then number 8, that's like an e over 3, so that's like a 2.7 over 3, so that's still a converge. Okay, take a look at number 9. So the sine of n, think about sine of n. It's not a p-series, it's not geometric, but if it's the sine of n, doesn't the sine function range from -1 to 1? It goes up to 1 and then down to -1, and then up to 1 and then down to -1. But either way, um, it's not geometric, right? It's not a p-series. And so in this case, what's going to happen? Well, it's going to be a diverge because the limit is always going to, it's not going to be 0. Okay, what about 9b? Well, hopefully, if sine always ranges from -1 to 1, then I'm just thinking of this as a 1 over n. And if I think of it that way, it's a diverge. And then the same thing on 9c, if I think of that as like a 1 over n squared. And so that's going to be a converge. Okay, so that's just kind of a quick refresher of things that might look a little different, but you can look at them very quickly and easily and know, oh, converge or diverge. Okay, so here we go. I'll kind of slow down my talking. Here comes the new part. This is actually section 9.5 notes. You may or may not have these. I have posted a blank copy of the outline, so you're welcome to print that, or else you can just kind of write down notes as we go. Because if you're writing down notes of your own, you may need to kind of pause this as you need to stay caught up, whatever you need to do. Okay, alternating series test is this. I want you to take a look at 2 different series that I have here. The first one where you have the -1 to the n. And I mentioned to you before, when you see this -1 to the n, all that does is it makes the terms alternate. If n equals 1, then you've got negative term. If n equals 2, then it's going to become a positive term. If n equals 3, -1 to the third is going to be a negative term. So these terms are just going to alternate negative, positive, and so on. Well, look at this one over here. It's almost the exact same thing, except it's -1 to the n plus 1. Well, it's still alternating. If n equals 1, then you actually have -1 squared, right? So it starts positive. But if n equals 2, then you have -1 cubed, which is negative. So the only difference in those 2 series is whether they start with a positive or a negative. But they're both alternating from a positive term to a negative term and back and forth. Okay, so if you look at my first example, I just want you to think through what these would look like. Let's write out the first five terms. So if n equals 1, then we're going to have negative 1, right? Because you got negative 1 to the first, 1 over 1. But if n equals 2, it's going to be a positive, and then you have 1 half. If n equals 3, you know it's going to be a negative 1/3. If n equals 4, it's back to positive, and then 1 over 4. And if n equals 5, it's back to negative, and then you have your 105, and we could keep going however. But you see in this case, they started with a negative, and then they just alternated. Okay, so how do we know if an alternating series converges or not? Well, there's two things you have to check, and I am guessing that because this is one of the few tests that they say you have to know, I'm guessing you're going to have to be pretty formal and actually show both of that you've checked both of these things. Okay, so the first thing that you have to check is um, does the limit as n approaches infinity equal 0? Okay, an alternating series, in order for an alternating series to converge, first of all, you have to show that the limit equals 0. Remember the nth term test said that if the limit does not equal 0, you know it's a diverge. Okay, so it has to equal 0 in order to converge, but just the fact that it equals 0 is not enough. Because if you think about it, 1 over n, we already know 1 over n is a diverge, and that limit equals 0. So you have to have more than just the limit equaling 0. The next thing is, the second thing you have to show is that the terms decrease in magnitude, meaning forget about the alternating part. That last one we did, we started with 1, and then we went to 1 half, and then to 1/3, and to 1/4, and to 1/5. So the terms were decreasing in magnitude, not paying attention to the positive or negative. The way that they tend to write that kind of formally is you'll see this notation where it says a sub n plus 1 is less than a sub n. Well, a sub n plus 1 is the term that comes after a sub n. And so they're saying, hey, is the next term less than the previous term? Okay, so in order for an alternating series to converge, you have to say that both of those are true. Because think about it, if the first condition fails, you don't even have to go on to the second one, because if the first condition fails, then if the limit doesn't equal 0, then it's an automatic diverge, right? Because of the nth term test. So if the question is, does this alternating series converge or diverge? And if you show that number 1 is not true, you're done, right? Because both of them have to be true in order for this to work. Okay, so let's look at an example, and I'll kind of show you how you would write it. Let's say I wanted to determine whether or not this alternating harmonic, right, because 1 over n is harmonic, and then the negative 1 to the n makes it alternate. So does an alternating harmonic converge or diverge? Well, what's the first thing I have to check? Well, the first thing I have to check is, does the limit equal 0? And when I say does the limit, that means ignoring the alternating part. Does just the non-alternating part equal 0? Well, in this case, yes, it does, right? 1 over infinity. All right, so that part checks out. Now, so because that worked, now I have to go on to the next step. Well, do the terms decrease in magnitude? In other words, is the 1 over n plus 1 term less than the 1 over n? Well, yeah. 1/3 is less than 1 half. 1/4 is less than 1/3, and so on. So that holds true. So here's what I want you to realize. Overall, that alternating harmonic converges. But remember, the regular harmonic, if it were just 1 over n, we already showed by a P series that's a diverge. But if it becomes alternating, then it becomes a converge. Okay, so you have another example. So let's go through the steps. The first step is, does the limit equal 0? Well, if all I'm looking at is n plus 1 over n, couldn't I think about horizontal asymptote rules? Well, that doesn't equal 0. So automatically, I don't even have to check the next one. It's a diverge. Okay, look at the next one. Now this one we need to kind of take things apart so we can see what makes it alternating and so on. So I'm going to think of this as, take the negative 1 separate from the 2, right? So you have this negative 1 to the n minus 1, and then you have this 2 to the n minus 1. And I put it out in front because it doesn't really matter if you have the negative on the bottom or out in front, right? It's the same thing. So because you have a negative 1 to the n minus 1, that's going to make it alternate. And so what we're really looking at, does n over 2 to the n minus 1, is that going to be a converge or diverge? Well, let's look at the limit of just that part right there. Okay, And if I just look at that part right there, not even the alternating, do you see that that part is going to be a converge? Why? Well, um, you could go back to what we talked about before, where you're comparing how fast the numerator is increasing compared to how fast the denominator is increasing. Um, and if you have n is linear, and in the denominator you have 2 to the n, right? That's exponential. If you have a linear over an exponential, isn't that always going to be a converge? So in this case, because it was a converge without even alternating, that means automatically the whole thing is a converge. Okay, so the whole alternating really only comes into play and becomes a question if the original would have been a diverge, but now maybe by alternating it can become a converge. Okay, next example. Look at this one. When you first look at it, you're like, how in the world is this alternating? Well, think about cosine of n pi. If n equals 1, you have cosine of pi. That's negative 1. If n equals 2, you would have cosine of 2 pi. Isn't the cosine of 2 pi positive 1? And if n equals 3, you would have cosine of 3 pi. So do you see, if n is odd and you're taking the cosine, it's going to be a negative 1. But if n is even and you're taking the cosine, um, it's going to be a positive 1. So in this case, the part that makes it alternating is that cosine of n pi. Now, based on what we did a few minutes ago, I'm going to say, hey, this is an alternating harmonic. It's going to turn out to be a converge, but let's check the tests. Okay, so let's check the test. The first test is, um, oh, sorry, I went straight to converge because of how we said it's an alternating harmonic. So the first test is, let me write it on there, is the series of 1, I'm sorry, not the series, is the limit of 1 over n minus 1 as n approaches infinity of 1 over n minus 1. Does that equal 0? Yes. And then are the terms decreasing in magnitude? Yes. Decrease in magnitude. You can always just do a couple of terms if you want to. Like say, what if n equals 2? Then you'd have 1. If n equals 3, you'd have 1 half. If n equals 4, you'd have 1/3. And we know they're going to be alternating, but those are definitely decreasing. Okay? Number 6, what makes this be alternating? Well, it must be that crazy sign part. So let's think about it. If you see this notation right here, just 2n minus 1, just that part, doesn't that mean odd number? No matter what you put in for n, won't you get odd? Because think about it. Whatever n is, when you multiply by 2, it's even, right? Whether n is even or odd, it doesn't matter. You multiply by 2, it's even. Okay, so now you have an even and you subtract 1. So won't that always be an odd? So this is going to go from 1 pi over 2 to 3 pi over 2 to 5 pi over 2 to 7 pi over 2. And think about the sine function. If it's sine of 1 pi over 2, it's positive 1. But if it's the sine of 3 pi over 2, it's negative 1. Keep going. If it's the sine of 5 pi over 2, it's back to positive 1. Sine of 7 pi over 2, it's back to negative 1. So something to kind of keep in mind, that notation, that sine of an odd pi over 2, is the same as saying that it alternates. And like we said up above, if it's an alternating harmonic, right, 1 over n is like a harmonic, same two reasons, we know it's going to be a converge. Okay, so that's it for today's new stuff. Okay, you'll see posted that you have an assignment, and they did come from the AP, from that College Board stuff, but it just seemed like that kind of became a pain for you having to actually access them. Having to actually access them through that website. So I thought it'd be easier if I just put them together in a document. You're welcome to either print this or just show your work and do the problems, and so then you can submit the answers to that on Canvas and not have to worry about the whole College Board thing. So again, as always, we will continue to have the optional Zoom meeting every A day at noon. You can jump on there if you have questions. If you don't, that's fine. Don't worry about it. Um, if we have I'm trying to think, depending on what kind of questions there are, I may try and and record those. But if it's just kind of a random, here and there, like not just several people at one time, then I probably won't record. But again, you're welcome to contact me, ask me whatever kind of questions, and I know you all know that. So, hey, you guys, I say it all the time, and I feel like you guys are doing a good job of this, but let me know how I can help. I really have a good feeling just in general about this class, especially now taking the AP exam, knowing what kind of time we have to review, knowing how we can still kind of keep this, I hope, to something manageable. So just let me know how I can help.